Let's say I have HOCl titrated with, so I won't be able to do a whole titration problem, but I'll do a partial one for fun. The Ka of this is equal to 2.9 times 10 to the minus 8. Let's say this concentration is 0.40 molar. And let's say we have 50 milliliters. Let's say this concentration is 0.20 molar, and there's 100 milliliters. I want to know the pH of these two mixed together. Well, this is a weak acid, strong base titration. Weak acid, strong base titration. By the way, how do I know this is a strong base? It's on that table, you gotta know. There's folios here who don't know that table. It's so good you came. It's in the middle of chapter 15. It's the strong acid, strong base table. That's how you know it's a strong base. How do I know this is not a strong acid? It's not on the table. There we go, it's that easy. That's how easy this class is. So, alright, how do I determine what to do? I'll start with the millimoles of both. So I multiply these two numbers, and I get 20 millimoles of this, and multiply these two numbers, 20 millimoles of this. That's how I determine what to do in a titration problem. I compare those two numbers. In this case, they're equal, so I call this point equivalence point. Okay? If that's where the color change happens, which ideally it should be, you could also call it the end point. Alright, so this is the EQ point. Now, those of you who from other, and you could choose either to write NaOH here, or you could write OH if you want to ignore the spectator. Okay, write those products.
Oh, yeah.
5 more seconds. Okay. So, the acid lost a proton, the base gained a proton. Acid-base classic reaction. You write the numbers down below. 20 and 20. What side is favored here? Right or left? Right. The right, because this goes 100% forward because there's a strong base in the reactants. It goes 100% forward. So I cannot do a nice table because there's no 0 on the unfavored side. So I am now doing stoichiometry. So I subtract a smaller number. They happen to both be equal. There's no weird 2 coefficients, so I don't have to worry about that. 0 and 0. These started off at 0, so I'm adding 20 to the right-hand side. I get 20 and 20. Okay. Notice now what happened. I'll get a totally different color. There is no, I don't know how, no, there's none of that. There's none of that. So there's no weak acid. There's no strong base left. There's only, what's this? Conjugate weak base. Conjugate weak base. Do we care about water? No. No, never. You could drink it, but I mean, we don't care about it. Do we care about sodium? No, never. I mean, it's just spectator ion. So now, I have to do what kind of problem? Solve for the pH. An ice table, because I have a weak base. So the person who asked me about the pH of a weak acid, I'm going to do actually the pH of a weak base right now. Okay, so I would say OCl minus, it is the only thing left. I'm going to write the part of the ice table. You can write the reaction. Here's the ice table. I'll make it look kind of pretty. Actually, not that pretty. You figure out what the rest of the reactants are or what the products are. I'll give you a moment. I'll write this number down. It's 20 millimoles, 50
got it wrong. You got it wrong.
Okay, I'll give you a hint. What goes right here? That's not a hint. What goes here though? Water. Water. Yeah, that's the only thing left is water. Okay, better write the products. My patience is ending. No, I'm cool actually. Gotta write the reaction in order to do the ice table. The base gains a proton. The acid loses a proton. Okay, so hopefully you can write reactions like this, or at least by the final. Ignore water, 0 and 0. You're gonna subtract here, add to the right-hand side. Remember the plus x always goes on the side where the 0 is. 0.133 minus x, x, and x. Okay? All right, K, what is the subscript? B, it's a base, which I'll get from KW over KA. KA was given in the problem, KW is given on the back of the final. It's 1.0 times 10 to the minus 14. KA, totally forgot what it was. It is 2.9 times 10 to the minus 8. It was given in the problem. This equals x squared over 0.133 minus x. What am I going to do next? Yeah, totally drop the x. I'm assuming it's smaller than 0.133. I can do that because k is small. That's true in other problems too. Sometimes you can do it when k is big as long as it's going away from the favored side. So if the plus x is on the favored side, this is how you know you can assume x is 0. If the plus x is on the, I should say, the unfavored side, and thus k is, it's really unfavored, where it is here, then the assumption will work fine. All right, so that drops out. I found what x is. X turns out to be 0. Oh no, I don't like that. 2.14 times 10 to the minus 4 molar. That's the equilibrium concentration of what important concentration? OH minus or H3O plus? OH minus, because that's what's here. That's X. Okay? So we go back. OH minus. So POH is the negative log of X, which is 3.67, and then pH is 14 minus POH, and that turns out to be 10.33. Is it okay that this number is bigger than 7?
Yes.
Yes, because? It's a weak base. So we got a weak base, I'm expecting a number bigger than 7. So at the EQ point, for a weak acid, strong base, the pH is bigger than 7. The reverse would be true for a weak base, strong acid. Okay. Let's see where we're at. Oh my gosh. I have no time, but I did this. Okay, for those who are left, who are not offended by what I just did, or have a review session after this, whatever, I'll probably cover like 1 or 2 more things, and then I'd like to go on to specific questions you have. First of all, let's vote. Exam 1 or exam 2? Exam 1, who likes that? Okay, exam 2. Oh gosh, that's pretty even. I think it's exam 1 though. Which one of these things do you want to see more? Okay, I'm only hearing Raoult's law and unit cell. Who wants Raoult's law? Okay, who wants unit cell? Oh, that's actually more for unit cell. Okay, cool, you win. And if you had a Raoult's law problem, you can ask me later during the practice. We'll do this. I guess. How do I know if the assumption will work? Yeah, okay. Quickly, the assumption will work if the molarity divided by K is greater than 100. That's true for a weak acid or a weak base. But more generally, if you want to include chapter 17, which doesn't have weak acids and weak bases per se, you would say if the plus x is on the unfavored side, and K makes it really unfavored. Meaning if K is like 10 to the minus 4 or smaller, it's going to be fine. Yeah. So if the plus X is on the unfavored side and K is pretty small, it's fine. Yeah. You can always check. So once you find X, see if it's really smaller than the number you thought it was. If it's not, that is quite unfortunate. You cannot do that. Okay? Alright, let's do a little bit of Raoult. The main thing I would encourage you to remember about Raoult, let's look at the equation. And then I'll write these down and I'll explain them. Okay. So let's review the equations first because it's been a little while and this is a classic, at least multiple choice question on a final. Alright, so the partial pressure, that's the partial pressure, in this case above the solution. There'd be I and there'd be J, so they're both contributing to the partial pressure above a solution where I and J are mixed together. The sum of I and J would be the total pressure. The sum of the mole fractions would equal 1. So the sum of I plus J plus anything else is always equal to 1. Now, the mole fraction is the mole fraction where? In the gas or in the liquid? Yeah, this mole fraction, we're talking about mole fractions in the liquid, not in the gas when we talk about Raoult's law. Okay? So in order to do a problem, we need to give you masses of that. Okay, this one is the pure pressure. So that's the pressure if only I was present in solution. That would be that vapor pressure. If I say that J is non-volatile, okay, I'll say that again. If J is non-volatile, P total equals what?
PI.
PI only. So a non-volatile substance means its partial pressure is 0. So if J is not volatile, then the partial pressure of J is 0. Okay, that happens sometimes, especially on simpler problems. Okay, so basically we would do something like this. P, I would say be 260 torr, and you mixed 2 moles of I plus 3 moles of J together. And so you want the total pressure, and let's say J is non-volatile. Sometimes it does not say that J is non-volatile, so what kind of substances would not be volatile? For example, how about organic compounds? Non-volatile. Any biological compounds, like a protein or something like that, non-volatile. So any bigger substances or substances that are not ionic, not really liquids by themselves. So glucose is another example. That's just sugar. So by itself, it's not a liquid. So it would have to be a liquid all by itself. So any sort of biological compound, molecular compound, organic compound. All right. So all you would need to do is find the mole fraction of I. That's 2 over the total moles, 2 plus 3. That'd be 2/5, or 0.4. Then PI would be the mole fraction of I, 0.4, times 260 torr. And that number, since J is non-volatile, equal P total. That would be a pretty typical kind of question on the test.